Hello everyone. This video presents an exploratory data analysis on the automobile dataset published by UCI Machine Learning Repository. I am Justin Jose and here are my digital coordinates on LinkedIn and GitHub. Before we move on to the analysis part, let's have a look at the dataset. This is mostly an insurance-oriented data published by UCI Machine Learning Repository. It is based out of a 1985 model cars and it has got 205 records and 26 variables. It's a CSV file and that can be loaded using Python libraries. The attributes list, I've highlighted some of the most important variables that I want to use in this analysis part. Data preparation steps, variable identification, I used symboling and price as the major variables to be analyzed, and other variables I used to find the relationship between these two. Univariate and bivariate analysis, you can refer the Python notebooks uploaded into the GitHub location. Treating of missing values, I formed groups of vehicles based upon relevant characteristics and calculated the mean or mode of the group depending on whether it's a continuous or a categorical variable, and then use those values to impute the non-numeric or missing values from the list. Outliers were detected and identified. Deriving of variables, new variables had to be calculated to carry out the analysis, like the risky, safe parameters, volume of the car, size group, etc. Now let's start with analysis 1. Does body size influence symboling? So this study aims to find the relationship between the body style or the physical appearance of the car or the body styling of the car with the symboling value. A word about symboling. Symboling is actually an insurance term. It represents how risky or safe a vehicle is. It ranges from -3 to +3. A vehicle having a symboling value between -3 and 0 is considered to be on the safe category, while those in the range +1 to +3, they indicate a risky vehicle. So on the left hand side, you can see the distribution of cars that fall into each of these categories. So -2, -1, 0 are all safer categories, while 1, 2, and 3 indicate risky cars. And you can see the counts of each of them. Now I introduced a new variable to mark every vehicle as either risky or safe. So any vehicle having a symboling value between -3 and 0 is considered as a safe vehicle, whereas those that fall between +1 and +3 are marked as a risky vehicle. On the left hand side, you can see that convertibles, hatchbacks, and hardtops are majority of fall into the risky category, while sedans and wagons, they are mostly safe vehicles as far as an insurance company is concerned. On the right hand side, you can see the central tendency of the symboling value. For safe vehicles, they are all zeros. They tend to 0, while the risky vehicles, they tend to 1 and 2, median and mode. Because these are categorical values, there's no point in calculating the mean of these. And on the bottom table, you can see the count of vehicles that fall into risky and safe categories. Now let's see the effect of number of doors on a vehicle. On the top left hand side, you can see the vehicles having 2 doors, and the right side, it has got the vehicle counts having 4 doors. So you can see that most of the safe vehicles have got 4 doors, while most of the risky vehicles have got 2 doors. And this trend is consistent even within each body style. So if you look at the bottom set of charts, convertible vehicles are all having 2 doors. Hatchbacks are mostly 2-door vehicles, and they are risky category. So red is risky and purple is safe. But when you come to sedans and wagons, majority of the vehicles are 4 doors and they are safe vehicles. So the key takeaway is that if majority of the safe vehicles have four doors, and majority of the risky vehicles have got two doors. Now, while the data says this, we can also infer that a two-door vehicle is mainly intended for a passionate driver who want to enjoy the pleasure of driving, while four-door vehicles are normally intended for carrying people around. And when we say people around, it involves families and children too. So, needless to say, a car that carries more people will be driven with more caution than an enthusiastic driver. Now let's see the impact of wheelbase. Wheelbase actually is the distance between the center of the front wheel to the center of the rear wheel. So this parameter indicates a lot of things about an automobile. As the wheelbase increases, the vehicle becomes stable on the road, and when but we sacrifice maneuverability of the vehicle. A short wheelbase vehicle can tackle curves and tight corners at higher speed, while a long wheelbase vehicle cannot. So if you see the trend here, all the risky vehicles, the red bars, all the risky vehicles have got a shorter wheelbase compared to their safer counterparts. It's consistent across all body styles. So when a manufacturer reduces the wheelbase, what they intend to say to the customer is that you can drive this vehicle. It will be nimble and maneuverable even through dense traffic as well as through tight corners. So you can drive at a higher speed compared to a longer wheelbase car. Let's compare the height of a vehicle to the risk symbol associated with it. On the left-hand side, you can see that the average height of the risky vehicles are always less than their safer counterparts. The red stands for risky and purple stands for safe vehicles. Now, on the right-hand side, you can see that as the height of the vehicle reduces, uh, the symboling values or the risk factors associated with each group, they increase, or meaning the risk goes up when the height comes down. So what does this mean? I mean, we can interpret this in many ways. But when the height of a vehicle reduces, or a shorter car has got a lower center of gravity, which means the car can stick to the ground even at higher speeds, even when we take tight corners at higher speeds, compared with a taller car, which has more probability to topple over when you drive it at high speeds and when you take tight corners. So this tells a speed enthusiast that they can do more adventurous driving with a shorter car. Wheelbase and height, that strongly correlated, and what we have seen now is that as the wheelbase reduces and the height decreases, the symboling value or the risk factor associated with the vehicle goes up. Now I'm introducing another variable here, which is volume, which is length into height into width. Now, this is not the real interior volume of a car, but it is sufficient to compare all the cars in this dataset. The graph on the left-hand side shows that as the volume of the car decreases, the symboling values goes up, which means the risk factor associated with a lesser volume car is higher compared to a car having a larger interior volume. Now, the two graphs on the right-hand side, we have already seen them. This is the correlation between the wheelbase, the height, to the risk factor associated with them. Now, if we bring all these variables together, this is how the graph will, and this is a 3D graph. The first level is for two-door cars, and the top level is for four-door cars. So the y-axis has got the number of doors in it, 2 and 4, and you can see that on the two-door level, the red dots are more, which indicates more risky vehicles belong to the two-door category. Lesser wheelbase, lesser volume, and as the volume increases, there tend to be more blue dots in it. And on the top level, on the four-door category, there are mostly blue dots, indicating that most of them are safer vehicles. And the red dots are tending towards a shorter wheelbase and smaller volumes. So the summary is, compared to safer cars, risky ones have lesser volume and they have two doors instead of four. Now, the summary of the analysis. Does body size influence symboling? Yes, convertibles, hardtops, and hatchbacks are riskier than sedans and wagons. And we also found that majority safe cars are found to have four doors, and the volume of a car. As the volume decreases, the risk factor goes up. Let's move on to the second analysis now. Do body style, size, and engine specifications determine car prices? So, in this analysis, we try to find the relationship between car prices and the styling of the body, their size, and engine specifications. So, because we are dealing with price, this slide shows the distribution of the price variable. So, on the left hand side, you can see that majority of the vehicles belong to the budget category between 5,000 and 15,000, 20,000 range. On the right hand side, we have a violin plot, which also demonstrates the same behavior. Majority of the vehicles are concentrated around this $10,000 mark. We have a short bump around $35,000, and the costlier vehicles are towards 40,000 and 45,000 range, but the majority is around $10,000. And the bottom graph also shows the same kind of distribution. The density is the towards the 10,000 mark. Body styles and pricing. We have the mean and the median of the car pricing across body styles. So you can see that the convertibles and hardtops have a significant price gap compared to the other three body styles like hatchbacks, sedans, and wagons. Now, body size, the length and width of the car with respect to pricing. There is strong relationship between the length, width, and the price of the car. So in this pair plot, you can see that the length and price of the car, they have a strong positive correlation. The width and price of the car, that also has got a strong positive correlation. So to study this further, I relied on the data provided by US Insurance Institute for Highway Safety, Highway Laws Data Institute. They classify car into mini, small, mid-size, large, and very large categories based on the shadow area and the curb weight of the car. The shadow area is length times width of the car. You can refer more on this classification in the given link here. So I introduced a new variable called size group, which where I calculated the classification based on what we mentioned now, like mini, small, mid-size, large, and very large, based on the curb weight and the shadow area. Now, the graph on the right-hand side, you can see the distribution of vehicles that belong to each of these categories. You can see that majority of the vehicles, they fall into either small or mini category. Now we compare the body size and the price. So on the x-axis we have the categories mini, small, mid-size, etc. And on the y-axis we have the pricing. You can see that the mini and small categories have got majority of the cars in it, and they are priced around or below 10,000 and 15,000 mark. Now, when it comes to mid-size and large category, their price range extends to the higher ranges like 40,000, 45,000 range. And there is a significant price gap between mid-size and large-size cars. And the key point to note here is that as the vehicle move from many small mid-size categories, as the size of the car increases, the pricing of the car increases too. Now let's compare the engine specifications with the price of the car. So here we take the engine size, horsepower, fuel efficiency, and number of cylinders to compare along with the price. So first of all, we take the engine size. Um, Engine size and price, you can see that there is a very strong correlation between the engine size and the price. Um, so on the right hand side, you can see the distribution of engine size here. So majority of the cars have got smaller engines. You can see that here the engine size is in cubic inches rather than cubic centimeters. So that's why you are seeing numbers in the range 100, 200, 300, etc. You can see that the density is towards the lower sized engines. On the right hand side, you can see a box plot which shows there are a number of outliers in the sedan category. And upon analyzing this, we saw that these cars have got V8 and V12 engines, which means they have got 8 cylinders and 12 cylinder engines. And so these are marked as outliers, those values are perfectly correct. They are not technical errors in the data. So we let them in the analysis. Now, horsepower and price. Again, there is a very strong correlation, positive correlation with horsepower and price. As the horsepower increases, the price also shoots up. Again, the distribution of horsepower, we can see that just like the engine size, the majority of the cars have got lower horsepower engine, lower powered engines. And the box plot on the right also shows a few outliers. These are again the V8 and V12 engines horsepower. Fuel efficiency and fuel efficiency surprisingly shows a very strong negative correlation with the pricing. So as the fuel efficiency goes up, the price of the vehicle comes down. Or I think it should be interpreted the other way: as the prices come down, the fuel efficiency goes up. This can be interpreted in a number of ways. One assumption is that most fuel efficient cars are sought by budget conscious consumers, and companies make products in lower price bands to cater to that category. The other assumption that we can make is um, as the prices go up, the size of the vehicle goes up, their power goes up, and hence their fuel consumption goes up. So all these are informed assumptions or guesses that we take on the data. The data doesn't support any of this, um, but that's left to us to make our own interpretations. On a side note, there are two variables provided in the dataset, which is the highway fuel efficiency and the city fuel efficiency, named as highway MPG and city MPG. These two variables have got very strong positive correlation. You can see that most of the dots are on the line itself. So that means we can actually use either one of them for comparison purposes. So I use the city fuel efficiency because that makes more real world numbers. Now we build a 3D graph based on all these parameters for the engine specifications. You can see that as the engine size goes down, lesser horsepower ones have got lesser price. And the blue ones, the blue to yellow range, that's the number of cylinders marked here. So you can see that the yellow and orange ones have got higher price. So the key takeaway here is the prices increase with increase in engine size, increase in horsepower, and increase in number of cylinders. Other thing to note here is that all these parameters are correlated with each other too. They are not only correlated with the price, they are related with each other itself. For example, as the number of cylinders goes up, the engine size goes up. As the engine size goes up, the horsepower also goes up. So these are all interrelated and correlated as well. The graph on the right hand side corner, it's a line graph showing um, the trend of engine size, horsepower, and the fuel efficiency. So engine size and horsepower goes up as the price range goes up, but the fuel efficiency comes down as the price increases. So summary of the analysis, do body style, size and engine specs determine car prices? Yes, we can see that convertibles and hardtops are priced way above sedans and hatchbacks and wagons. As the size of the vehicle goes up, or bigger vehicles, they are priced above smaller vehicles. We also saw that the horsepower and the number of cylinders, they have strong positive correlation with the price. So you can see that the dots go up and then there's a strong positive correlation here. So with that, we conclude this analysis. Thank you for watching, and here are the references which I use for this analysis purposes, and you can find the notebooks, the Python notebooks that I created during this analysis process in the given GitHub locations. Thank you.